Hello everyone, greetings from VNR JYOTHI Institute of Engineering and Technology. This is Manohar Reddy, Department of Cybersecurity, Data Science and AIDS. In this session, I am going to continue the topic on disk scheduling algorithms, which we left in the last session. So continuing the session, scan and looking algorithms. The third scheduling algorithm, the third disk scheduling algorithm is the scan algorithm. So in the scan algorithm, the disk arm moves in a particular direction and services the requests coming in its path and after reaching the end of the disk. So here the scan algorithm disk arm moves in a particular direction. That means in a particular direction and service the requests coming in its path. So each and every path it allocates and reaching at the end of the disk, and it reverts its direction, again service the request arriving its path. So how it is going to the direction, particular direction, and it takes the same reverse direction also. It is reaching the end of the disk and reverse its reach direction and again services the request arriving its path. So this algorithm works as an elevator. Its algorithm works as an elevator. So how elevator works? So it is going to take up the men to the up and then again it reverse direction. It comes in the reverse direction. So hence also known as an elevator algorithm. So scan algorithm is also known as elevator algorithm because the disk arm moves in a particular direction and the services the request coming in its path after reaching the end of the disk. So if it is reverse the direction, it reverses its direction and again services the request arriving its path. So because of this phenomena, it works like an elevator. It is called as elevator algorithm. So as a result, the requests at the mid-range are serviced more and those are arriving behind the disk arm will have to wait. So as a result, the requests at the mid-range are serviced more and those arriving behind the disk arm will have to wait. So we'll see how it works. So take the example here, the disk input output requests are here, the service requests are here, 82, 170, 43, 140, 24, 16, 190, and the reader writer arm is what? 50. So it is also given the disk arm should move towards the larger value. The disk should move towards the larger value. So how it moves? So 52 to first, the initial head position is what? 50. So from 50 to next 50 to 82. So from 50 to 82. The next this is the first moment. The next 82 to 142, 82 to 142. So the direction towards end of the disk and again it takes the reverse path. So this is the second path. So from 82 to 142 is the second path. From 142 to 170 is the third path. And 170 to 190 is the fourth movement, and from 190 to 195 is the fifth movement. So all this will comes into the right direction. So path direction. After reaching the end of the disk, it has to take the reverse direction. To its original positions or to its remaining value. So now after reaching to the end of the disk 199, it has been reversed into the direction from 199 to remaining values. What are those remaining? 43. So 43, that is the value 6th position, and from 43 to 24 is the 7th position, 7th movement, and from 24 to 16 8th movement. From 24 to 16 is the 8th movement. So like this, all the disk arms will be moved from larger value towards the larger value into the same path direction to the end of the disk. After reaching the end of the disk, it has been take the reverse direction of its original path towards its remaining values. So this is the path direction that has been moved to the end of the disk. After reaching the end of the disk, it has been take the reverse process reverse path as its original or its remaining values. So because of this, it is called as elevator algorithm. So how it goes and its same direction, same reverse direction it comes. How it goes and its same reverse direction it comes. So because of this, this algorithm is called as elevator algorithm. Advantages of scan algorithm. So through this we can achieve high throughput and low variance of response time. Low variance of response time and average response time also. Average response time. And disadvantage is what? Head may move to disk end unnecessarily. So there is no need of moving end of the disk. But through this, the head may move to the disk end of the disk unnecessarily. High waiting time for some requests. So here if you observe this, for 14 and 16, 24, for 24 and 16, it has been waiting 8 position. It has been waiting so much time for completing this position, right? So because of this, high waiting time for some requests, and new requests may wait longer. New requests may wait longer. So this is the scan algorithm for. So scan algorithm is also called as elevator algorithm. So all the movements are taking the direction, taking its path direction to the end of the disk, taking its path direction end of the disk. After reaching the end of the disk, it takes the reverse path direction towards remaining values. The next one is what? C-scan algorithm. So C-scan is nothing but what? Circular scan. C-scan is nothing but what? Circular scan. In this scan algorithm, the disk arm again scans the path that has been scanned. So the disk arm again scans. So here 2 times scan. Circular scan is nothing but what? One time normal scan is happen. Again circular, because of the circular implemented, the disk arm again scans the path that has been scanned. So after reversing its direction, it has been scanned one more time. So it may be possible that too many requests are waiting at the other end, or 3 may be 0. So it may be possible that too many requests are waiting at the other end, or there may be a 0 or few requests pending at the scanned area. So maybe sometimes it may be completed, all the requests have been scanned, or else it may be some of the 0 or few requests have been pending at the scanned area. So these situations are avoided in the C-scan algorithm. So which the disk arm, instead of reversing its direction, goes to the other end of the disk and starts servicing the request from there only. So not like that, not like a scan algorithm. It starts servicing the request from where it is ended. It starts servicing for another disk positions. So the disk arm moves in a circular fashion, and this algorithm is also similar to the scan algorithm. Hence it is known as C-scan algorithm, that is circular scan algorithm. So how it works, we'll see here. So take an example. So in the scan algorithm, all the disk movements are towards the end of the disk. After that, it takes the left direction. That means it's the reverse direction of the path, and close the path direction. But in the circular scan, again it scans. So after reaching towards the remaining value, it start performing scanning again. So if you see here, the 50 is the reader right arm is 50, and from 50 to 82 is the first step, and from 82 to 142 is the second step, and 142 to 170 is the third step. From 170 to 190 is the fourth step. 190 to 199 fifth step. So this is the end of the disk. Unnecessarily the disk can be moved to the end of the disk. So this is the unnecessarily thing we have to do. So after reaching towards the end of the disk, it has been take the regular path, reverse path into its original 16. That means the original path. So this direction, this step is what? Sixth step. And from 16 to 24 it is the 7th step, and from 24 to 43 it is the 8th step, and 43 to 24 to 43 is 9th step. So like the way it has been moved from starting to the ending of the direction and reverse, taking the reverse direction, and again start to servicing, again it start to servicing for the remaining values. So because of this we can say that it performing one more time, and because of this performing one more time we can call it as circular scan. We can call it as circular scan. So suppose the request to be addressed are 82 or and the read arm is 50, and at that disk arm should move towards the larger value. So as it is scanner algorithm, it towards the larger value. So the total overhead movement, total distance overhead by the disk arm is calculated as 199 minus 50 plus 199 minus 0 plus 43 minus 0. If you calculate all this, we will get 391 is the total overhead movement. Total overhead movement, that is nothing but total disk covered by the disk arm, 391. So advantages. So it eliminates starvation of requests. So it eliminates starvation of requests. So because it start again servicing towards remaining all the other values, and better performance for heavy disk loaded. Better performance for heavy disk load. And more fair than scan algorithm. More fair than scan algorithm. Yes, right. And the disadvantage is what? Extra head movement due to return start. Due to return to start. So again it has to start from servicing, starts for servicing process. So it takes time. It takes time. Extra head movement also required. And increased seek time compared to scan. Increased seek time compared to scan in light board. And more overhead because of circular movement. More overhead because of circular movement. So this is the circular scan algorithm. Now next algorithm we will see the look algorithm. So look algorithm is similar to the scan disk algorithm, except for the difference that the disk arm, in spite of going to the end of the disk, goes only last request to be serviced. Last request to be serviced in front of the head, and then reverse its direction from there only. So in the scan algorithm, C-scan algorithm, what will happen? The service is up to the end of the disk. But here the look algorithm is not up to the end of the disk. The service is for the last request to be serviced. Last request to be serviced. So thus it prevents the extra delay. It prevents the extra delay which occurred due to unnecessary traversals to the end of the disk. Unnecessarily traversal to the end of the disk. So there is no extra delay. It prevents the extra delay which occurred due to unnecessary traversals. So this is the look algorithm. So we will see how it works. The same values 82, 170, 43, 140, 24, 16, 19. So what we are taking here in this part, so the service to the end of the service is not to the end of the disk. The service is requested for the end of the request, not to the end of the disk. So if you see in this all values, 190 is the last one. So it starts from 50. The first step is what? 50 to 82, and second step is what? 82 to 170, 82 to 140, and third step is what? 140 to 70, and fourth step is what? 170 to 190, and the fifth step is what? 190 to 43, because it has been taking the reverse direction. It has been taking the reverse direction from this one. So then next 143 to 24, sixth direction. The next 60 to 24 to 16. So this is the seventh direction. This is the seventh direction. So all these directions are not ended up to the end of the disk. They are up to end of the service. Up to end of the service. So 190 is the end of the service. So we are reaching towards end of the service and taking reverse back. Go to the end of the service. So end of the service is what? 16. So like the way we can go or utilize the look algorithm. So to calculate what we have to calculate, or how we have to calculate the difference, 190 minus 50 plus 190 minus 60. So here 190 minus 16 and here 190 minus 50. So that is the difference, like 140 and remaining what? 174. So that is what? The overall head movement. Overall head movement is what? 314. So comparing with that one, it is somewhat better. So if you see advantages, reduced unnecessary movement. It reduces unnecessary movement. So unnecessary movement The scan algorithm is what? So going to the service offered to the end of the disk, service offered to the end of the disk. So here it reduces unnecessary movement and faster response also. And disadvantage is what? Waiting time can still be high for some requests. So waiting time is what? Somewhat still high. And performance depends on request distribution. Performance is depending on request distribution and not completely fair to newly arrived request. So not completely fair to newly arrived request. So these are all the advantages and disadvantages of look-o algorithm. We'll see C-look algorithm. So a look is similar to the scan algorithm, and in similar way C-look is similar to the C-scan algorithm. C-look is also similar to the C-scan algorithm. So how C-scan works? So it starts from disk position to the end of the disk position, after that taking the reverse direction. So that is the scan algorithm. But in the C-look algorithm, the disk arm, in spite of going to the end of the goes only to the last required to be serviced. In front of the head and the form, there goes to the other end of the last request. So that means the arm is going to the end of the request, and it is serviced by in front of the head, and then from there goes to the other ends of last request. So one side end request and one other side end request. So taking the path direction end request and taking the reverse direction end request. Thus it also prevents the extra delay which occurred due to unnecessary travels to the end of the disk. So whatever the disadvantage comes in the scan algorithm or C-scan algorithm, that will be rectified by the C-look algorithm. So now we'll see how it works. So if you see the arm positions, so it does not goes to the end of the size first of all, and it gives the services to the end of the position, and also it taking the reverse direction to the end of the position. So how it works? So see here, the first movement is what? 50 to 82. The second position is what? 82 to 170. That is the second position. 82 to 140. And the third position is what? 140 to 770, third position. And 170 is the 170, and 170 to 190 is the fourth position, and 190 to reverse direction, 190 to 43 is the fifth position, and 43 to 24 is the sixth position, and 24 to 16th is the seventh position. So like the way each and every disk arm movements are towards end of the disk, but not to the end of the disk. Towards end of the disk services offered, and taking the reverse direction to the end of the services offered. So if you calculate all this, so total overhead movement equals to 190 minus 50. So 190 minus 50 is nothing but what? 190 minus 50. Right, this is the overhead movement. And similarly 190 to 160. So 190 to 160. So 190 to 150, 190 to 160. Total equals to 314 is the overhead movement. The advantages are what? Uniform wait time. So all requests have to be waiting uniformly, and reduces head movement. And the disadvantages are what? Extra head movement due to circular scanning. Because of the circular scanning goes to the end of the process, right? And for this purpose extra head movement is required, and it increases seek time compared to look under the light load. So it increases seek time compared to the look and other scanning algorithms also. And newly arrived requests may have to wait for a full cycle. So these are all the scheduling algorithms that are look and C-look algorithms, scan and C-scan algorithms. Use the below links for more data about these disk scheduling algorithms. FCFS, shortest seek time first, and scan algorithm, C-scan algorithm, look algorithm, and C-look algorithm. Right. So I hope all of you understand. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.